to problem set 9. We're going over problems from problem set 9. This should be on page. Anybody know the page off the top of your head?
36.
Thank you. No, not
42.
46. All right. 45, 46. All right. Opening it up. Guys who are watching the live stream, if you're there, nobody's there right now. Okay, great.
No, it's not 42.
He? That's 45 and
I think it
46.
starts on 42.
The lesson starts
It
on
starts
42.
on 42.
Yeah. But the problem set starts on 45. Those are really what I want you to have in front of you, is have the problems themselves in front of you while we're going over. All right, anyone wants to go over? Yes.
Number 18.
18. All right, we've got -6 minus 4 minus 3 minus -3 plus 3. All right. Somebody tell me where to start.
Start with start by making it to like -6 plus -4.
Okay, so I'm gonna change my subtraction to what?
Addition.
Addition of a
Negative.
negative. So instead of -6, let's say plus -4. Plus negative. Plus negative. Okay, now all of my subtraction is no more. Excellent. I hate subtraction. Now what do I do?
Negative. That's going to be -3 right there.
Where?
In the parentheses after 4.
Right, so we can ignore these parentheses now, because it's just -3 now. What about over here?
That's going to be positive.
Right, -3 means +3.
And then plus 3.
Plus 3, all right. So then, do we need to simplify it all before we add up together?
Yeah. If you add the two 3s together, you have 6, and then you could just cross out the negative 6.
Oh yeah, that's true. So we get 6 from these guys. Eliminates that -6. Whoa, that's crazy. And then -4 and -3 together give us -7. Okay, you could have also done it by combining your negatives. You get -13, and over here you get +6. -13 and +6 will also give you -7 as your answer.
Oh, okay. I figured out wrong.
Either one of those is fine. But yes, so pay attention for things like he mentioned, where these two, adding 3 twice cancels out a -6. Pay attention to things like that. Make your life easier. Okay, any others? Anyone wants to go over? Yep.
26.
26. All right, finding the area of this oddly shaped figure. Saxon loves this kind of stuff.
What? Oddly shaped figure.
Oddly shaped figures, yep. Interpret that however you want. All right, so we've got 5, 8, 12, 2, 7, and 6. All right, now, they say all our corners are right angles, and our dimension is what? What unit are we using here?
Meters.
Meters, all right. And what do they ask us to find here?
Area.
The area. Okay, so now do we have a formula for the area of this weird backwards L-shaped hexagon?
Times height.
Length times width will give us the area of what?
Polygon.
No.
Square or
Square or a
rectangle.
rectangle, right. So, but this is not a rectangle, is it?
No.
Okay, but what can we do? Put that away. What can we do?
Length times width times height.
Length times width times height is going to give us the volume of something 3-dimensional. What can we do here to get the area of this? We don't have a formula for this weirdly shaped thing. So what am I going to do?
Multiply everything.
Don't do that. You're going to get something way too large. Think about it. What's an easier way to think of this weird L-shaped thing? Two
rectangles.
rectangles, right. Okay, where do we want to divide them?
Right there where the 12 and the 3. No, that's a 2. Or 7.
This is a 7. So here? Here?
Yeah.
Okay, so we're going to cut them here. Now, area is the same. Right, just by cutting down that line, you don't change the area. Okay, now we've got 2 rectangles. So this is rectangle 1, we can call it rectangle 1, and we've got rectangle 2. So the area of the whole thing should be the sum of these two areas, right? If we add together area 1 and area 2, we should get the whole area. Now, rectangle 1, what's its area?
14.
14, how'd you get that? 14 what, by the way?
It's 14 meters squared.
14 square meters, how'd you get that?
2 times 7.
2 times 7, that's the length and the width. All right, so 14 for rectangle 1, what about rectangle 2?
30. 40.
Yeah, hold on.
It's 40.
Which
No,
one do we do?
Yeah, 40 meters.
it's 40 is 5 times 8.
So be careful with this guy, well, with both of them really. Make sure that when you're multiplying the length and the width, you're getting the length and the width of the whole rectangle. This second rectangle here, don't use 12 for the width, because 12 is the width all the way along here. We just want this width here, which is 5. And similarly for the height, or the width, whatever you want to call it, this dimension, we want all the way from the top of that rectangle to the bottom. If we use 6, 6 is only going to get us up to here, and we're forgetting this little chunk here. So we need to do 5 times 8, and it gives us what?
5 times 8.
40. Sorry.
40, so our answer is
54 meters.
54 square meters. And the way that we did that was just like with these perimeter problems, where we don't have a formula for perimeter of a lot of these weird shapes, so we break it up into things that we do know how to find. Same thing with the area problems, and we'll go over this a bit today when we do lesson 8, which I skipped. Mea culpa. We can do this by breaking it up into smaller things that we know how to find the area of, and then just adding them together. Next.
Number 27.
27. Okay, we'll talk about 27 today. That's a triangle. What's the formula for the area of a triangle, anyone?
Length
times
times
height divided by 2.
Right. You can write as base times height over 2, or you can write as 1/2 base times height.
Oh, that's right.
That's a triangle. Okay. All right, I'll take one more from problem set 9, and then I want to go over some problems from the test. Anybody wants to go over any of those? Last call. If anybody's watching on the live stream. Oh, I got 3 guys watching on the live stream. I think this is an all-time record. If there are any problems from problem set 9 that you want to go over, now is your chance to type in right after you like, subscribe, and save. And
Would you be mad if you didn't?
what?
Would you be mad if someone disliked the video?
I don't care. I mean, I guess I'd be a little hurt. Don't give them ideas. Okay.
You can turn off like this.
I know.
You can't
I know. Okay. Last call.
This show's in it for the in.
Going once. Going twice. All right. Take out the test. Let's go over the test. Everybody should have their test back. Problems you want to go over from the test. You want to see how to do them. I'll take out my copy. Hopefully I got that somewhere.
It's due tomorrow, right?
Huh?
Yeah, we can.
Corrections are due tomorrow. Yeah.
Oh, yes, okay. I have something to do, but I didn't know it. My mom is not
Okay, so that'll go to Mrs. Friedland in the front.
I don't think I can do corrections.
I can go.
That's what I agree.
You can go right now. Yeah.
Oh, am I able to do corrections or?
Yes. Yeah.
I got a 95.
Okay. So, any problems that you got? At least one. Okay. Obi-Wan Kenobi says no. I'm good. Thank you very much, Obi-Wan Kenobi. He's got it. He's even got it in the really curly font. All right.
Yeah.
So, how about test? Test questions anyone wants to go over?
Number 6.
Number 6. It's still yours.
Oh, thank you.
All right. Number 6. So now we're dealing with test. Test 6. All right. The radius of a circle is 9 inches. Okay, we've got a circle. It's got a radius of 9 inches, and we're finding the circumference. Now, the radius is what? If I'm drawing this circle, it's got a center. It's got this, curvy shape to it. What is the radius going to look like? Let's get the visual here. The radius is where?
The radius is like a line. It's like half of the diameter.
Right, it's half the diameter. It goes from the center to the edge. Okay, that's what's 9 inches. we're trying to find the circumference, the measurement around. How do we find the circumference given the radius?
You multiply r by 2,
And?
and then multiply that by pi.
Right, so we have two formulas for the circumference of a circle. Either 2 pi r or pi times diameter, which are the same thing.
But this is divided by 2.
No, that's for a half circle.
Right, we've got the whole circle here.
Oh.
Yeah, so it'll be 18 pi inches there. Yeah, we'll only divide by 2 if we had a semicircle and we wanted to find the perimeter of that round side.
Let's add to the square.
Okay, next. Test problem.
I did the same for number 7.
Aha! Yeah, so just make sure that we've got
You
this.
say the answer to number 18,
18 is 5.
and then 17.
Want to go over 17? I don't want to just like feed you guys the answers. Okay.
No, I already did it, like I did it the other correction.
Okay. So walk me through it. We've got 12 and 1/4 divided by 4 and 2/3. All right, so what's going to happen? What am I going to do to divide these two mixed numbers?
They're gonna have to make them into what's called fraction.
Into improper fractions, what will they be?
49 with 4,
Yep.
then 14 with
Yep. Now what am I going to do to divide these two fractions?
3, 4, 3. Flip it 14 with 3 into 3 with 14.
That's it? What else? What do I do with the first fraction?
Keep it all there.
Keep it. Division becomes multiplication, and then yes, as you said, we flip, keep, change, flip. Okay? Then what do we get? Can we simplify it all before we multiply these? What can we do?
7 goes into 49. 7 times
7 goes into 49 7 times, and it goes into 14 2 times. All right. 7 times 3 on top is?
1.
All right. 4 times 2 on the bottom is? 8. Yep. You can leave it like that, or you can change it to an improper fraction, in which case it'll be what? Sorry, as a mixed number.
It will be 2,
2 and?
5,
5, 8. Yeah. You make sure with your corrections you're showing all your work. Yeah, seriously, no phones in class. I can see the live stream. Ding dong. All right. If you're one of my 3 viewers, then the reason why I have this all-time high is going to make me a little sad. Okay. Anyway,
shoot.
what?
What if?
Yeah,
I have
wait.
my phone in my
Who else?
backpack.
Maybe it's some hello stranger, new friend. Okay. Anyway, like, subscribe, and save. Okay.
Save what?
I don't know. Isn't that what they say?
No, they say like and subscribe.
Like and subscribe
And leave a comment.
and leave a comment. Okay. No,
Save
don't
it
leave.
to what?
No, don't leave comments. I don't want comments.
You want all the comments.
No, I'm pretty sure you can't save the video because then you'll get it like on your feed or whatever.
You can
Yeah,
watch
there we
later.
go.
You can save it in your watch later.
Save it into your watch later list. There you go. So you see all the ads again, and I get the revenue again.
Wait,
Okay.
you
All
do
right.
that?
Last call for questions about the test. Yes.
Numbers 8, 9, 14.
Okay. 8, 9, 14. Okay.
And 18 and 19 and 20.
Okay. Why don't we pick 2 of those? I think 8 should be one of them.
8, okay. And
The internet can hear you.
and 9.
8 and 9. All right. So 9.
Oh, yeah,
9. This is just one of these things about numbers that we should know. So when we talk about counting numbers, what's the other term that we have for counting numbers?
Whole numbers.
Whole numbers are a little bit different.
Natural numbers.
Yeah, keep this distinction in mind. So when we talk about natural or counting numbers, what is that going to look like? We start with what? What's the lowest number in that set?
1,
1. The next is?
2, 3, 4, 5, 8.
Yeah. When we talk about whole numbers,
Wait,
we actually mean something a little different. Whole numbers is like this, but it includes what?
Fractions?
Not fractions.
Negatives.
It includes 0.
Oh.
When we include negatives, then what are we talking about? Integers, right.
Oh.
Integers. So integers,
I have a question.
yep.
That's what I put on the test, but you said it was like, I don't know.
Okay, just show it to me afterwards and I'll fix things. Okay,
I have a question.
yeah,
Why did
quick-
a bald man just sneak into our room?
okay, number 8. Father, we're live streaming, so
The internet can hear you.
Blessings.
blessings, peace and blessings. All right. Test problem 8, unit conversion. 2 unit multipliers to go from 45 yards to inches. Okay, we're not going to go straight from yards to inches. First of all, they tell us to use 2. What are we going to do? We're going to go from yards to what?
Yards and feet.
Yards to feet, and then feet to
Inches.
okay, to set up one of these unit conversion problems, please set up unit conversion problems like I'm showing you because,
45 yards over 1.
yeah, you'll trust the system. Okay, sometimes don't, but in this case, do trust the system. 45 yards over 1. Now, to change from yards to feet, what are we going to do?
By.
Something cool.
Multiply.
Multiply by?
Multiply by
Feet.
1 yard
3.
on the bottom.
By what?
1 yard at the bottom. Or okay, well,
3. He
so
said 3.
It's
David said 3.
3 feet over 1 yard.
Right. We always in inches instead of yards. So this is actually 1. How can we tell that this is equal to 1?
Yard.
Because 3 feet is equal to 1 yard. When the top and the bottom are the same, the whole fraction is equal to 1. Now we put yards on the bottom because we're trying to get rid of yards. This yards on the bottom will cancel out the yards on the top and leave us with feet. Now we've got feet. To go from feet to inches, what are we going to do?
12 over 3. What? 12 feet over. 12 inches over 3.
12 inches over
1.
One.
over 1 foot. The top and the bottom of each fraction must be equal to each other.
Yeah.
So 12 inches is 1 foot. We're getting rid of feet, so we put feet on the bottom. Feet and feet cancel out. The only unit we have left is inches. That's good. That's what we're supposed to have. Now, it's just like multiplying fractions. So we multiply across the top, 45 times 3 times 12. And on the bottom, 1 times 1 times 1, we can ignore that. Inches. Trust the system with the unit conversions. Whatever unit you're getting rid of will be on the top of the previous fraction, and so you want on the bottom of the new one so they cancel out. Make sure the top and the bottom are always equal to each other. 3 feet equals 1 yard. 12 inches equals 1 foot. Also make sure you know consistently, by memory, all of those unit conversions that are listed in that chapter. You should know how many feet are in a mile. You should know how many centimeters are in an inch. And if you don't know those, learn them. Because I'm not going to tell you. With the other ones that you mentioned, those ones mostly are working with fractions in various ways. So 14, we're multiplying fractions. 19, we're subtracting fractions. And 20, we're also subtracting fractions. Okay, be careful with number 20, because they tell you what CE is, that's the whole thing, and that CD is that first part, and DE. So look at the visual there, and you realize they gave me the whole thing, and they told me what this part of it is. Sorry, for those of you who are watching. They give me the whole thing, they tell you how much this part is, and then what they're asking is how much does the remaining part measure. So we'll do the whole thing minus this part, and we'll get that part. So make sure with those ones, because sometimes with those types of problems with the line segments, you're going to have to add, sometimes you're going to have to subtract. So make sure you look at it and figure out which one you're going to have to do. Okay, let's go to problem set 8. If you have other questions about the test, we might have some time at the end here, but let's go to 8 quickly, because there are a number of different things to go over here. So this is page 36 in the textbook, talking about area. Area. Now, area is distinct from perimeter. When you talk about perimeter, what does perimeter mean?
Distance around.
The distance around something, if we're going to run around the outside of something. The area, though, is what?
The distance inside.
Not a distance, it's the space inside it. Right, when we're talking about area, area is a two-dimensional thing. A line doesn't have area because it's one-dimensional. A point doesn't have area because it's zero-dimensional. Area has to be of something flat. So the floor has an area, the ceiling has an area, the window pane has an area, the board has an area. Okay, so when we deal with area, we're going to have square units. For example, square feet, square meters, square centimeters, etc. Because a centimeter or a foot, that's a measurement of distance, it's not a measurement of area. If we talk about a square foot, 1 foot this way and 1 foot this way, now we've got a square that we're measuring the area of. Okay, for rectangles and squares, so well, rectangles in general, because a square is a type of rectangle, yes? The rectangle is a quadrilateral with all right angles. Rectangles, how do we find the area? Length times width. And now for if the square, the length and the width will be the same. Okay, a triangle on the other hand, how do you find the area of a triangle?
Base times height divided by 2.
Yeah, base times height over 2. Now when we talk about the base of a triangle, usually we just mean the bottom. The height is the height. One catch is you got to make sure that the base and the height are at right angles to each other. So if we have a triangle like this, for example, this is the base here. The height is this distance. The height is not the length of that slope there. The height is literally the height of it if it's standing on the base. And they got to be at right angles to each other. The reason why it's base times height over 2 is because we can think of a triangle as, oh look, half of a rectangle. You take a triangle, you duplicate it, you put them together, you've got a rectangle or a parallelogram. But we'll see about parallelograms in a minute. So triangle is base times height over 2. Circle. What's the area of a circle?
R squared.
Pi, r squared. Be careful, do not get this mixed up with diameter, 2 pi r. Those are not the same. Multiplying by 2 and squaring the radius are not the same between the circumference and the diameter for every single circle.
I have a question.
Yep.
Up top, you put the area of a rectangle is 1 times width.
Length, that's an L,
Oh.
lowercase l. Let me just make it a little more L-y.
And I thought that the area of a circle is circumference.
Oh, it's good.
No, the circumference is the perimeter, is the distance around the outside. The area is how much paint we're going to have to cover to paint that circle. These are not the same, these two formulas. Those are not the same. They use the same symbols, but arranged differently. 2 pi r means 2 times pi times r, whereas pi r squared is pi times r times r. In both of them, we're multiplying pi and the radius. It's that third thing that we multiply that's different. Whether we multiply by 2, that'll get us the circumference. If we multiply by the radius again, though, we get the area. Don't get those two formulas mixed up. I see guys do that all the time. Don't do it, please.
Okay.
I'm begging you. It hurts my teacher heart. All right, last thing. Last two things. Parallelograms
Okay.
and trapezoids. Parallelograms. All right, parallelograms are actually also going to be length times width, although we usually talk about it as base times height. So parallelogram, that's kind of ugly, but we're gonna deal with it. The base is like the length of a rectangle, and the height, just like when we're talking about the height of a triangle, is not the length of one of these sloped sides. It's actually at right angles to the base. Okay, the height is that top to bottom thing. The reason why, this is the same as the rectangle formula, notice. We're just calling them base and height instead of length and width. The reason for that is that if we take a parallelogram, watch what I can do. If I chop off this part of it, this triangle, and I stick it over here,
No. No.
no way! Isn't that cool? Isn't that amazing?
Yeah,
Shapes just
so
equal other
fascinating.
shapes.
Yes. The other way we can think of this parallelogram, remember a triangle is base times height over 2.
Yeah.
Base times height, the area of this triangle is half the area of the parallelogram. So we take this and multiply it by 2, we end up with just base times height.
Wow.
Okay, the last one, and the most difficult one, trapezoids.
Oh, sure.
Okay, trapezoids are annoying because they have 2 bases that have different heights. We've got base 1 and base 2, and then we've got a height. The area of a trapezoid is base 1 plus base 2 times height divided by 2.
Oh.
The reason why that works is because we're taking our trapezoid and we're actually duplicating it over here, and now we've got a parallelogram. And the area of this parallelogram, well, the height is the same. Here's base 1, here's base 2. So we do base times height. That gets us the area of that whole giant parallelogram, but we only want this first trapezoid part, so we divide it by 2. This is the most annoying of the of them. You can also think of a trapezoid as made up of 2 triangles. They show you that in the book on page 41. But anyway, the big ones to know are these first 3, because all the other ones are based off of it. And really, the triangles is based off of the rectangle. So really, rectangles and circles are the most important ones to know. Triangles, parallelograms, and trapezoids are all based off of this same rectangle formula. Circles do their own thing. So when they give you problems like, if you flip to page 42, right at the top of page 42, we've got a practice problem. Let's do that together, and then I'll tell you guys what the homework is. Why is this not working today?
Can you just not?
But what will I do with my free time?
Spend time with your family.
Alright, so that last practice problem there, they give us this weird figure.
Split it. I know what to do.
Okay, we've got 2, 4, and 7. Yep.
Split into a triangle and a square, so they're separate.
A triangle and a square.
So you see that little
A triangle and a rectangle. We could do that. Let's leave it as a trapezoid though. Notice we've got a trapezoid.
Oh, you can add them together and then divide it by 2, and then you get the area of one side.
So what's the area of that first part of that trapezoid? How do we find the area of a trapezoid?
You add the 2 bases.
Add the bases, 4 plus 7,
and
multiply by the height, which is what?
4, and then you divide that by 2.
Notice that the height is 4. We know that because the radius of this circle is 2. So that's 2 this way and 2 this way. The diameter of it is 4. That's the height there. All right, so the area is what? 11 times 4 divided by 2?
Is 11 times 4.
Divided by 2 is what?
11 times 4 is
22.
22.
All right, now the second thing, what kind of a thing is this second thing?
It's a radius. It's a half the circle.
It's a semicircle, so how are we going to find the area of it?
You're gonna have to multiply. No, you're gonna have to do
That's
pi
me too.
r, you're gonna have to do.
Pi r squared
Divided by two.
divided by 2. Okay, what's the radius?
2.
So pi times 2 squared divided by 2, 4 pi over 2, 2 pi. So the area of the whole thing is 22 plus 2 pi what?
Squared.
2 pi what? What's our unit?
Centimeters.
Square meters. Square meters. Because all those lengths are meters, so the area is square meters. All right, let me pass out the problem sheets, and then while you guys get started on.
Are you sure you wanna do that?
You can do other things with your time.
Are you really sure?
Spend time with your kids.
Do you have to?
I know.
Wait, whoa.
I'm choosing to.
What do you mean?
Okay. First up, the first problem there, just while I get this written up, is going to be number 3. 3 and then
Could you give us
7.
less problems?
What?
Could you give us less?
Fewer problems?
Less.
No, fewer.
Yeah, just give us 2 problems and that's it.
There's sticky stuff on my chair.
Okay, so problem set 8. The numbers I want you to do are 3, 7, 8, no, 3, 7, 8, 9, 10, 13, 14, 16, 17, 18, 19, 20, 22, 23, up to 27.
Might as well just also do the whole part of that one.
No! Don't give me ideas. All right. Goodbye.
How much time do we have left in class?
About 7 minutes.
Yeah,
Seven,
yeah,
yes,
yeah.